All right. If you did not follow me well in the previous video, so summarize one more time. If you use an unstabilized Ylid, so this negative charge here is not stabilized by a carbonyl next to it. There's no carbonyl here. All right. So we call unstabilized Ylid. The stereoselectivity of this reaction will be on Z isomers. The selectively makes Z. Okay. And the reason is, well, because of the electronic repulsion and stereokindrance, the best conformation where the two reactant, the carbonyl and the Ylid collide is look like that. And with this conformation, you can do the reaction, and the product got the two alkyl group next to each other. So that's why you get Z. Okay. So if I ask you what control the stereoselectivity of this Ylid, the unstabilized Ylid, the electronic repulsion, right? So we have electronic repulsion and stereokindrance. Okay, so they control how these two reactants collide. Now, stabilized Ylid though, how do we get to E isomers? It's E selective. Okay, same thing. So the only difference is I convert the alkyl group to high electron density carbon. Okay, we have this one is ester carbon. Okay, so the same thing. The Ylid high electron density at the top, the triphenylphosphine, high electron density for from the carbonyl, the electron withdrawing group. Okay, and the aldehyde ketone, same thing, high electron density on oxygen, stereokindrance on the alkyl group. So we agree on that from the previous video that you don't line them up like parallel. No, you don't, because the triphenylphosphine and the oxygen will repel. Okay, so the best collision angle, it has to be, one of them has to be perpendicular, look like that. Now, which one the best though? Which one the best minimize the electron repulsion and the stereokindrance? The first one, not for sure, because oxygen and the electron withdrawing group, which is high electron density, they line up. So we got electronic repulsion there. So nuh-uh. Okay. The next one down here, so we have an alkyl group close to the triphenylphosphine. No, doesn't look good there. Right? There's a repulsion there. The third one, same thing, alkyl group next to triphenylphosphine. Nuh-uh. The last one though, well, actually that's the best one, right? So we avoid electronic repulsion between triphenylphosphine and oxygen. The electronic repulsion between oxygen and the electron withdrawing group. Right now, the only repulsion we have is the stereokindrance. Yeah, and I think you guys know resonance usually dominate pretty much other effect. The electronic effect usually dominate everything, right? So we have electronic effect here, somewhat electronic effect there, somewhat electronic effect there. This one we don't have any electronic effect because we'll have some, but not a lot. The alkyl group has low electron density compared to electron withdrawing group, so this is probably the best conformation. Okay, the best colliding angle. All right, we're gonna move forward with this. Okay, so oxygen will take pi electrons, attack phosphorus, and we take Ylid, so carbon, Ylid, carbon, attack the carbonyl. Okay. All right, I'm not going to move anything yet, so I'm going to just put the line together. So we have from oxygen phosphorus bond, carbon bond right there. This is trans. This is E isomer. If you can't see this is E, watch. So oxygen, we have to move up to phosphorus to make a four-membered ring, right? This is a weird four-membered ring. The four-membered ring is supposed to be kind of semi-flat. So oxygen have to move up to phosphorus. So this bond have to rotate. Okay, hydrogen will go replace the alkyl group. The alkyl group go replaces oxygen, and you get E isomers. Look like kind of like trans to the electron withdrawing group. Okay, and then the last step is retro to +2, and you get the product. Ta-da! Here we go, E isomer. All right. That's how to explain why stabilized Ylid favor the E isomer and unstabilized Ylid favor the Z isomer. Before you move on, or maybe like tonight when you want to review it, I post this on Canvas. So make sure you go read a little, and it should be really simple reading now because you understand how it works now. All right, this one just like a little bit more detail, but it will reinforce what you just learned from the slide. Okay. All right, let's go to the next video. I have just slightly a little application of physics reaction.